The odds of dying as an aircraft passenger in the US is almost too small to calculate. However, if you do die in a plane crash, it will likely happen during the first 3 minutes or last 8 minutes of flight. The takeoff and descent make up just 2% of the entire flight, but accounts for 13% of all fatal accidents. Landings are about 4% of the average flight, but are responsible for 48% of fatal accidents. This is because takeoffs last just 30 to 35 seconds. If a problem arises, the pilot has almost no time to decide what to do. This significantly increases the chances of a dangerous error taking place, and the same can be said for the landing phase. Ultimately, it's both easier and safer for a plane to cruise than to land or take off. Imagine you're in the air and both engines shut down. Because of the high velocity, the plane will continue to glide. A typical airliner loses about a mile in altitude for every 10 it moves forward, giving the pilot a little over 8 minutes to react. When aviation accidents do occur, they are typically caused by a combination of factors, primarily human error, mechanical failure, and inclement weather. Human error is the most common cause, accounting for about 50% of all accidents. Mechanical failures alone do happen, but they account for just a small proportion of airliner crashes. And just as driving becomes more dangerous in bad weather, so does flying. Although today's airliners are able to safely operate in nearly any weather conditions, small aircraft have to be far more careful. Fortunately, there are a number of modern technologies that help reduce the aforementioned risks, especially during the first and final moments of flight. One critical piece is the instrument landing system, which helps guide pilots during periods of poor visibility. It effectively creates a cone of radio signals that help pilots remain within a safe glide path corridor, even if visibility is poor. For dangerous or short runways, airports often install an engineered materials arrestor system. This is a foundation of materials at the end of a runway to decrease the severity of the consequences of deviation. It's designed to collapse under the weight of an airplane, gripping its tires and ideally bringing it to a stop. Other safety solutions include Air Surface Detection Equipment Model X. This technology creates a real-time map of all aircraft traffic and movement on runways. It uses a variety of surface surveillance radar, ground-based position sensors, and automation systems to give pilots and control tower staff an awareness of everything that's going on around them at all times. Future developments include using a mixture of things like sensor data, electronic ignition, and engine control with a type of surveillance technology called automatic dependent surveillance broadcasts to make landings of the future almost fully automated. Such technology, it's hoped, will help reduce pilot error to an absolute minimum.